Welcome to this channel, and let me first make sure if we are correctly going live or not. Yeah, let me just check it. Yeah, it's working. Okay, so in this live video we are basically going to solve uh, MIT integration B problems from 2010. So first of all, I already have two videos where I have solved problems from 2010 and 2011, and in this video we are going to solve problems of MIT integration B from 2012. Yeah, and I have the list already over here, and here are the solutions as well to check the answers. So let's begin. This is our first problem. Okay. Yeah, to solve this problem, basically, first of all, we will want to simplify the root x. So for that, we can just assume y as root x. Then we will have y square equals to x. Now we can differentiate both sides to get 2y dy equals to dx. Now we'll use this to simplify the integral. Dx will be 2y dy, and root x will be y plus 1. Sorry, y minus 1. Yeah. Now we can take 2 out of the integral. That gives us y minus 1 plus 1 by y minus 1 dy. Now we'll have 2 times 1 plus 1 by y minus 1 dy. That gives us 2 times y plus ln y minus 1 plus c, and the y is actually root x, so that gives us root x plus ln of root x minus 1 plus c. So this is the answer. And now if you want to check this answer, we can basically just go to the website. 2 times root x plus 2 times ln of root x minus 1 plus c. Yeah. Yeah. Sir, which your question is this? So this is basically MIT integration B 2012 problems, yeah, from the year 2012, and these are pretty good problems even for IIT or any other competitive exams. Yeah. So we have solved the first problem here, and if you want to look at it again, you can just go back in the video and then watch it. Let's go to next problem. So this problem looks like it should be solved from integration by parts. And why? Because there's log x and x to the power 1 by 4, and this can be differentiated and the other one can be integrated. Yeah, so we can guess that we have to use integration by parts, and log x will be u and the other one will be v. So now integral of basically the integral of u v is equals to u times integral of v minus integral of du dx and then integral of v. Yeah, and so this will be integral of x to the power 1 by 4 log x dx will be, we will have log x as it is. The integral of x to the power 1 by 4 is x to the power 5 by 4 by 5 by 4 minus, and the integral of, now the derivative of log x is 1 by x. Yeah, and then integral of x to the power 1 by 4 is x to the power 5 by 4 by 5 by 4 dx. Now this is 4 by 5 log x to the power 5 by 4 minus 4 by 5 integral of x to the power 1 by 4 dx. And now you can integrate this again. That gives us 4 by 5 log x to the power 5 by 4 minus 4 by 5 x to the power 5 by 4 by 5 by 4 plus c. So this is the answer. 4 by 5 log x to the power 5 by 4 minus 16 by 25 x to the power 5 by 4. So let's check the answer. 4 by 5 log x to the power half by 4 minus 16 by 25. Yeah, so that's the correct answer. Yes sir, I'm preparing for JEE and I want to give Olympiad from India. Maths Olympiad, but calculus is fun, so I want to enjoy. Yeah, in Olympiad basically you are not asked questions from calculus. Yeah, that was easy. Yeah, and like some problems are easy, some problems are hard, and some are average. Yeah, yeah, that's nice. That's nice. That's nice if you solve it faster. And Math Olympiad will do something different. To yeah, you can just search Vedantu Olympiad School, and you can get idea from there as well. Yeah, yeah. All the best for Olympiads, and yeah, do enjoy these problems as well. Now let's go to next problem. The next problem is this one. Yeah, so let me copy it. Okay, so the first idea that you might want to use in this problem is to let root x. Yeah, because you might want to simplify this expression, so you can just first let root x as y, and I've already done these problems before, so I do know that if we let root x as y, that will be simple. So you can just first let y equals to root x. Now you will have dx by 1 plus y root under y square minus y to the power 4. Yeah, and y square equals to x is there, so that implies 2y dy equals to dx. So you can also change dx as 2y dy. Okay, and now after this, what you can do is you can just take y square common out from denominator. Yeah, 2y dy by y plus 1, take the y out, and then root under 1 minus y square. Yeah, now let me increase the screen size. Okay, and now we can just cancel the y, and that gives us integral of 2 dy by y plus 1 times root under 1 minus y square. Now over here you will need a little bit of technique. Yeah, basically because here's 1 minus y square, it like you there it can be helpful like to make the same thing over here as well. Yeah, that was the reason that why I did this in my approach, and that actually worked. So you can make 1 minus y by 1 minus y square. Yeah, root under 1 minus y square dy. Okay, now the next step can be to just let, if you just let this g as 1 minus y by root under 1 minus y square. Now because it's going to be squared by using quotient rule, so you will get this term as well, and when this numerator is differentiated, you will also get root under 1 minus y square. So basically, like you with practice you can see like how it's actually will give something related to the original expression. Basically, let's just differentiate this. Now we will have root under 1 minus y square v, and then derivative of u minus u, and then derivative of b. Yeah, and by b square. So now you see we have got this expression. Yeah, this expression, and also when you take LCM you will also get this expression from here. So that was why I did this. Yeah, and if you don't understand, you can watch it again, like why. Yeah, and now this will be, here's minus 1, so 1 minus y square will be y square minus 1. Yeah, and then minus 1 minus y by, this is 1 minus y square, and then 2 times root under 1 minus y square. Yeah, yes. Okay, now we'll have this equals to y square minus 2 plus y. Yeah, is it? Did the 1 not cancel out? So we have 1 minus y equal to y square, and then y square minus 1. Yeah, is that it? Yeah, I guess that it is. Yeah, fine. Yeah, okay, fine. Let's go. I think this will be solved. But basically, the minus 2 could have been cancelled. Yeah, but let's approach though. Yeah. So 2. Here's dy. 2 1 minus y square. Root under 1 minus y square dy. Okay. So now, basically, like when I did this problem, there was just y over here, and then we had 2y minus 2. Yeah, but it's not that right now. Let me just check where did I go wrong or what mistake I could have made. Yeah, okay, fine. So that okay, so I made a mistake over here. Okay, so when I was differentiating root under 1 minus y square, I did 1 by 2 root 1 minus y square, and then by chain rule we also have minus 2y over here. And yeah, when we have minus 2y over here, this will be y square. Yeah, let me write it again. Minus 1 and then plus 2y, plus 2y, and then minus 2y square. Is that it? Yeah, minus y square minus 1. And then also, because when taking LCM, we had 2 also over here. So using that, this will be 2y square minus 2 actually. 2y square minus 2. Okay, now it's going good. Yeah. And then dz equals to 2y square cancels out. So we have 2y minus 2. 2y minus 2 by 2 times 1 minus y square root under 1 minus y square dy. Now the 2 cancels out. Now when we cancel out the 2, we'll have dz equals to y minus 1 by 1 minus y square root under 1 minus y square dy. Now at this point you will realize that this expression is already there. Yeah, in our original integral. Yeah, this expression is already there. Yeah, if we take minus 2 common out, we have y minus 1 by 1 minus y square under 1 minus y square dy, which is exactly what we have over here. So we can write that as minus 2, and then the other expression is just integral of dz. Yeah, integral of dz. Okay, so now this will be minus 2z plus c, and what's our z? Our z is 1 minus y by root under 1 minus y square. 1 minus y by root under 1 minus y square plus c, and then multiply by negative sign, we will have 2 times y minus 1 by root under 1 minus y square plus c. So is that the answer? Yeah, I guess that's the answer. Let's check it from the website itself. 2 times, and now we can substitute y as root x. Yeah, we can do that as well. Now y is actually root x. Yeah, so if we substitute that, we'll have 2 times root x minus 1 by root under 1 minus x plus c. So that's the answer. Now we can check the website. That's the answer. Okay, so thank you, sir. I have got scholarship Vedanta Olympiad for this year. In ninth grade. Let's see. I can get in. Yeah. You can try. Yeah. Obviously, like there have been people who have got into IMO in eighth and seventh grade as well. So it's not really impossible, but it will be tough. Yeah. And if you have got scholarship, that's really nice thing. Yeah. Just try. Um, just try to do good. Okay, so yeah, thanks, Ideal Me. Yeah. Here I go, keep following us, and we will solve all the integrals from 2012 MIT integration B. Let's go to the next problem. Okay, so now for this problem. This problem is also about letting. Yeah. Now basically in this problem we have dx by root x and multiplied by root 4 of x plus 1 to the power 10. Now just to make it simple, we can let this as y first. Yeah. So you can just let y equals to x to the power 1 by 4. Then you will get y to the power 4 equals to x, and then 4 times y cubed dy equals to dx. Okay. And then dx will be 4y cubed dy by root x will be y square. Yeah. And then this is y plus 1 to the power 10. Yeah. And now you can just cancel that out. That will be 4y dy plus y plus 1 to the power 10. Now you can try to make y plus 1 in the numerator as well, and then subtract 1. Yeah, and that gives us 4 times integral of y plus 1 to the power minus 9 minus y plus 1 to the power minus 10 dy. Now it's easy. Now there's really nothing to do. 4 times this will be y plus 1 to the power minus 8 by minus 8. Sorry for whatever happened. Okay, and then minus y plus 1 to the power minus 9 by minus 9 plus c. That should be the answer. Yeah. And then you can just take the LCM, like to match with the answer from the answer key. So this will actually be minus 1 by 8 y plus 1 to the power 8, and then plus 1 by 9 y plus 1 to the power 9 plus c. Okay, so now if we want to take the LCM, this will be okay, so if you want to take the LCM, that will be 72, isn't it? Yeah, that will be 72. 72 times y plus 1 to the power 9, and that gives us minus 9. Yeah, minus 9 y plus 1. Over here that will be plus 8 plus c. Okay, so, and that gives us 4 times, that will be minus 9 plus 8, that's minus 1, isn't it? Okay, so, isn't that y plus 1? Again, let's find that list too. That is minus 9y minus 9 plus 8. But why does it not match with the answer? The answer key. Wait, did I again make a mistake? No, I did not. Okay, so we can take 4 out, yeah, and then integrate it part by part. I don't think I made a mistake, but maybe in my answer key there might have been some mistakes. First of all, let me check the answer, what it is. Okay. Yeah. Actually, I'm doing it right now, and in my copy there was mistake. Okay, fine. And then by 72 to y plus 1 to the power 9 plus c, and then that will be, we can just cancel 4, and then that will be 4 1s are 4, 4 1 4 32. I'm sorry for that. I'm sorry for that. That does happen sometimes. Okay. Okay, fine. We will move on. Yeah. Okay. Now we were cancelling 4 4 1 4 4 32. Yeah. And that's minus 9y minus 1 by 18 times y plus 1 to the power 9 plus c. I can take minus 1 common, and that gives us 9y plus 1 by 18 times y plus 1 to the power 9 plus c. Let's take the answer. Yeah, okay, now, yeah, that's correct actually. So now we can just let y as x to the power 1 by 4 plus 1 by 18 times y plus 1 to the power 9 plus c. So that's the answer. Yeah. Okay. And okay, so I forgot to substitute y as x to the power 1 by 4 here. Yeah, that's the answer. We can check it here. Yeah. Now let's move to next question. Okay. So basically, Mr. from Bihar. Thank you, Raghu. I finished waiting for the answer. Okay. Oh, does it feel easier for you? That's nice to hear. If it feels easier, and okay. Hi, bro. The way ours are solved. Oh, big subscriber from India. So thank you so much. Can you make this resolved? Okay, so please don't spam in the comment section. So yeah, please don't spam over there. Let's move to next problem. Now, this problem is kind of easy. Yeah. Okay. Now for this problem, so whenever x belongs to range 0 to 1, we can use that sine of cos inverse x is just root under 1 minus x square. So this is valid when x is in between 0 to 1. So you can just use that over here. Yeah, you can use that property, and that comes because we can just use turn cos inverse x to sine inverse x, sine inverse of root under 1 minus x square, and now these two cancel out. That gives us root under 1 minus x square. So that's how we get it. And then this is integral from 0 to 1 of root under 1 minus x square dx. Now we have to find the area of the graph y equals root under 1 minus x square. And this is actually y square plus x square equals to 1, just the circle. Yeah. And from 0 to 1, and also that this is positive, this is not negative. So we just have to find this area. Yeah. So the area of full circle will be pi times 1 square. That's pi. But area of quarter circle will just be pi by 4. Yeah. So that's the answer, which is pi by 4. And if you want to go from the formula, you can also go like this. So if you want to go from the formula, you can use the formula that is integral of a square minus x square. That is x by 2 root under a square minus x square plus a square by 2 sine inverse x by a. You can also use this formula. Over here we have root under 1 minus x square dx. So this will be x by 2, and it's going from 0 to 1. X by 2 root under 1 minus x square plus 1 by 2 sine inverse x. Yeah, from 0 to 1. So at 1, this is going to 0 and this one will be pi by 4. Yeah, minus at 0, this will be 0, it will also be 0. So you see we get the same answer, pi by 4. Yeah, and I hope you enjoyed this idea from the geometry. I do have a separate video about solving some of other integrals as well using geometry. Hope you will check that as well. Now let's go to the next problem. This problem, let's check the comment section. Oh. Okay, so please spamming. Okay, don't spam first. Drawing legend Hanumanji, I'm a bit more than the first half. You have been a bit more than so God, please don't really spam over here. I think I messed up somewhere. Okay, you can just rewatch it if you have messed it somewhere. Yeah. Okay, fine. I think if he doesn't really stop spamming, I can also remove Sogat from the comment section. But let me not. Yeah. Let's wait if he turns out to be good. Yeah. Let's go to next question. This question. Now for this problem, this is actually a pretty easy problem from the high school itself. Yeah. First of all, we need to try to complete the square. So you can take minus common over here, and then we have x square plus 4x minus 1. Now we'll try to complete the square. That gives us dx by root under minus of x square plus 4x plus 4 minus 1. Yeah, and then we will have dx by root under this is minus 5, so we will have 5 minus x plus 2 whole square. Okay, now that gives we can now use the standard formula, that is dx by root under a square minus x square. The formula for this is 1 by a, okay, not even 1 by a, just sine inverse x by a. So I think this one should be pretty easy, and we'll just get the answer easily. So answer will be sine inverse x plus 2 by root 5 plus c, directly from the formula itself. So this one is pretty easy. You can check the answer also. Sine inverse x plus 2 by root 5. Yeah, that's the answer. Next, we'll go to next problem. Yeah, this one is pretty interesting problem. It's not hard, but it's quite interesting. Yeah. Just trying to not root subscriber. Okay, so let me remove Sogat. Yeah, remove. Yeah, Sogat will be removed. Yeah. Okay, message deleted by. Okay, so no, I just wanted to remove him. Hide users. Let's put a digit in timeout. Yeah, confirm. Okay, now I think that would do our task. Yeah, that's fine. Let's move ahead. Hey, समझ गए ये problem. That's nice. Let's skip. Yeah. Oh, you can still do. You can just go back and was it easy? That's nice to hear. So now let's go to next problem. Okay. Now for this problem, the integral is going from 1 by 4 to 1 by 2. We also have these symbols. So this is actually g function, which is greatest integer function. And this function returns the integer which is smaller than this number, but the greatest integer is smaller than this number. Yeah, the greatest possible integer is smaller than this number, so that's 2. Yeah, and let's say if we have 3.1, that would be 3. Even if we had 3.9, that would be 3. So this is how GIF works. We have to find the greatest possible integer smaller than the number. Yeah, smaller than the number. So that is it. Now over here we have GIF of log of, and then again GIF of 1 by x. So when it goes from 1 by 4 to 1 by 2, there will be numbers like 1 by 3 over here. Yeah, okay. And then this is greater actually. Yeah, and then over here we'll also 1 by 3.5. We also have 1 by 2.5. Is it? Yeah. It's fine. So these are in the order of increasing. Yeah. Now we have to see like what will be the value of GIF of 1 by x in these range. So let's try to see. So let's say if we have some number in between this range, something like 1.1 by 3.9 or 1 by 3.8. In that case, we will have 1 by 3.9. Yeah. So that will be just GIF of 3.9. So that will just be 3. Even if we have a GIF of 1 by 3.5, we will just have GIF of 3.5. So that's just 3. So this means to say that for every number from 1 by 4 to 1 by 3, our GIF of 1 by x will just be 3. You can see that over here. And similarly, from 1 by 3 to 1 by 2, the GIF of 1 by x will just be 2 itself. So that's the actual hint for this problem. Now we can break the integral into integral from 1 by 4 to 1 by 3 plus integral from 1 by 3 to 1 by 2. Yeah. And then we have GIF of log, and then for this range GIF of 1 by x is going to be 3. Yeah, we already found out that. So log 3 dx. And for this range we will have GIF of log of, and the GIF of 1 by x is gonna be 2. We have already found that. So log 2 dx. Okay, that's nice. Now let's move ahead. Okay. Now if we try to find GIF of log 3, if we try to find GIF of log 3, let me just find it out soon. Yeah, now the GIF of log 3 will be 0.477. Is that it? No, basically that should not be. Okay, 1.09. So GIF is GIF of 1.09 dx, and over here this one is integral to, and then log 2 is 0.69. So GIF of 0.69 dx. Now GIF of 1.09 is 1. This is just 1 dx, and the other one is just 0 dx. 0 dx. Yeah. Let me again increase the screen size. Okay. Now 1, that's just x from 1 by 4 to 1 by 3 plus, what's the integral of 0? That's just constant from 1 by 3 to 1 by 2. Yeah. And over here this will be 1 by 3 minus 1 by 4. Over here that will be c minus c. Okay. And now that this is 1 by 12, that's the answer. I hope you enjoyed this problem. This was pretty nice problem though. So 1 by 12 is the answer. Okay, 1 by 12. 1 by 12 is the answer, fine. But could not qualify. Is that like you can just try the YouTube channels like shapes of problem solving. Let me write it over. Shapes of problem solving, and you can also like practice past year problems from Nepal Olympiad, or you can also do books like the EGMO, yeah, or some inequality problems, or there are also I am a compendium on the Google. Okay, DM'd you. Okay, I'll check that. I'll check that. Can you search social media in my personal handle? Hmm. Okay. You can just comment in one of my videos, like what are the problems that we have. I will try to reply you in the comment itself. I think that will be a good idea. Okay. So basically, you can comment in one of my videos, Trigonometrics, and I will give you full detail over there. Yeah, not now. Like you can just comment in one of the videos, and I will give you full detail over there. Okay. You can get me up later as well. You can just watch this video anytime. Okay. Hmm. Nice. Yeah. Now let's go to this other problem. Yeah. Okay, sorry. Now for this problem is not that hard. Just you can change sine to cos, yeah, and then the problem will be solved. And the other way is just to multiply by the conjugate, 1 minus sine x. So both of the ideas do work. Yeah. We have integral from 0 to pi by 2. That will be 1 minus sine x. 1 minus sine x by 1 minus sine square x dx. Now 1 minus sine square x, that will just be cos square x. Yeah. By cos square x dx. So now this will be integral from 0 to pi by 2 of sec square x minus sec x tan x. Now this one is easy. We all know what the integrals are for these two trigonometric formulas. The sec square x, it's tan x, and sec x tan x, it's just sec x. It's going from 0 to pi by 2. Yeah. Now tan of pi by 2 is infinity, and sec of pi by 2 is also infinity. So that seems to be a problem because infinite minus infinite is indeterminate. Yeah, but you cannot just write. If we had only one term, we could have like written it as infinity. But over here we have infinity minus infinity. Yeah, so that's indeterminate, and we need to take limit. So let's take limit x tends to pi by 2 of tan x minus sec x. So this is how we approach, and this is what the use of limit is actually. So limit is made for these purposes. Though tan x and sec x individually are not defined in pi by 2, but we can take the limit for the difference of these two numbers and we'll get some value. I'm pretty sure about that. So we get limit x tends to pi by 2. This is sine x minus 1 by cos x. Now this is 0 by 0 form, so you can use L'Hopital's rule. We get limit x tends to pi by 2. This is cos x, and this is cos x, and this is minus sin x. Okay, now again this is just again minus cot x. Yeah, that doesn't make any difference. So let's try some other way. Rather than using L'Hopital's rule, we can just try to simplify in other ways. Can we use other ways? What can we do? Maybe we can like change this sine x to cos of pi by 2 minus x. Let's try to do that. Yeah. Let's try if that works. Pi by 2 minus x minus 1 by cos x will be sine of pi by 2 minus x. Do you guys have any suggestions on how do I take this limit? Do you guys have any suggestions? Done. Is that like okay. Did you just change sine into cos, or you did in the same way? So limit x tends to pi by 2. So 1 minus cos x, that minus 2 sin square x by 2, minus 2 sin square pi by 4 minus x by 2 by, and this will be 2 sine pi by 4 minus x by 2 cos pi by 4 minus x by 2. Yeah. Now let me just increase the screen size. If it doesn't work this way, we can solve by changing sine into cos. Yeah, that would work. And now this will be limit x tends to pi by 2, and over here, okay, so basically in our earlier approach we had cos x by sin x, so that was actually working, don't you think so? So when we applied L'Hopital's rule, we had cos x by sin minus sin x. Yeah. So now in this, if we substitute x as pi by 2, we will have cos pi by 2. So that's just cos 90, which is 0 over here. That's minus 1. So we get 0. Yeah, that's actually works, I guess. Yeah. So we had 0, but does that give the right answer or not? Okay, so let's see. So that gives us 0. Yeah. Basically, L'Hopital's rule was working earlier. When we used L'Hopital's rule, we had cos x by minus sin x, and now we put pi by 2. That's 0 by minus 1, so that's 0. Now it's 0 minus, and then tan 0 is 0 minus sec 0 is 1. Yeah, okay. So 1 is the answer. So let us see if that's the correct answer or not. If yes, we had made a great use of limit. Yeah, that's working. And we also saw a great use of limit. Yeah. Now let's go to the next slide. This problem is based on King's rule. You can see that directly. Yeah. Both way works. I convert it. Okay. So that's nice. Okay. So now for this problem, you can use King's rule. And how do I see that? Because the number over here is just the sum of these two numbers. That gives the idea that King's rule should be used. But let me introduce you to what King's rule is. King's rule is basically taught in IIT JEE or also in undergraduate level for any other country. So if you have integral from a to b of f of x dx, this integral is also equals to integral from a to b of f of a plus b minus x dx. And if you want to know the reason why this works, you can just take antiderivative. Antiderivative of small fx is said to be capital Fx, going from a to b. Over here also capital F of a plus b minus x, and since the coefficient of x is minus 1, just take minus 1 in denominator, going from a to b. This gives us capital F of b minus capital F of a, and that gives us negative of, this is capital F of a minus capital F of b. So you see both of them are actually the same. Yeah. Now we can use this property, King's rule. Sorry. I was actually trying to use lasso. Okay, so now let's try to use the property. Now I equals to integral from 1 to 2011 of root x by root under 2012 minus x plus root x. Yeah, this is f of x. Now this will be equals to f of a is 1 plus b is 2011 minus x. So this will be equals to f of 2012 minus x. Yeah. So this will be equals to I equals to 1 to 2011. So f of 2012 minus x means in place of x you can place 2012 minus x. Over here also you can place 2012 minus, in place of x you can use 2012 minus x, plus in place of x you can use 2012 minus x. Yeah. Now this will be equals to integral from 1 to 2011 of root under 2012 minus x by, this over here is just root x plus root under 2012 minus x. Now Now if you add these two integrals, 2I equals to, initially we had 1 to 2011 root x by root under 2012 minus x plus root x, and the other integral is integral from 1 to 2011 root under 2012 minus x by root under x plus root under 2012 minus x. Yeah, and now we are near to the solution now. Yeah, now 2I equals to integral from 1 to 2011 root x plus root under 2012 minus x by same thing root under, this is actually same, both of them are actually same, root x plus root under 2012 minus x. So you see, now this simplifies a lot. This is just integral from 1 to 2011 of 1 dx. So that gives us 2I equals to x from 1 to 2011. That's 2011 minus 1, that's 2010. Yeah. So 2I equals to 2010 means that I equals to 1005. That's the answer. And you can check this answer, 1005. Yeah, okay. Okay, I'm in. That's nice. You can enjoy the problems. These are pretty good problems from MIT Integration B. Yeah. And now let's go to the another problem from MIT Integration B. Yeah, we are currently in problem number 9. That's already done. Problem number 10. Yeah, and this problem is quite nice, and this is also somehow long problem. Yeah, now let's try to do it. Okay. Yeah, now for this problem, what we can do, what we can do is we can first try to bring x out. Will that help? We can bring x square out. Yeah, let's try to go. We can first try to bring x square out, and since here's square root, we'll just have x here, and then x plus 1 plus 1 by x dx. Then we will have x minus 1 by, we will have x square plus x, this is actually x, yeah, plus we will have x plus 1 by x. Now the next step we can do is, basically while I was solving this problem, I was just trying to let the things, if they simplify, and if we let this as y, it's gonna simplify a lot. I think we can do that at the beginning itself. I have not tried that, but I think that it will help to do it at the beginning itself before even starting. But let's try to let it here. So if we let y as root under x plus 1 by x, we will have dy equals to 1 by 2 root x plus 1 by x, and then that will be 1 and this 0, and then minus 1 by x square. Yeah, so this is our dy, and now we can write this as dy equals to, this will be x square minus 1 2 root x plus 1 by x times, that's x square dx. Okay, so now we can try to substitute this in place of dx. in place of dx, we can try to substitute this expression, yeah, and I think that will help us. Well, let's see if that does or not. X minus 1, x square plus x, yeah, so that will be 2x square by x square minus 1 and then dy. Okay, now let's try. I'm going a bit deeper. Now we have this. Now we can cancel one of the x minus 1s, and also we can cancel the x. So we have 2x by x plus 1 and x plus 1 dy. So we have now 2, and this is x square plus 2x plus 1 dy. Yet x is also there. Now this is actually 2 by x plus 1 by x plus x plus 1 by x plus 2 dy. Yeah, and now if we look at it a bit closer, look and clearly, we will see that this is actually 1 by x plus 1 by x plus 1 plus 1 dy. And this expression over here, sorry, actually sorry for that. Okay, so where was I? Okay, so now this is 2 by the x plus, okay, so that's occurring too frequent now. I think I should copy it and do it in the other slide, or else it's not gonna let me work. Yeah, let us just delete this first, so that we do have enough cache memory for this to work on. Okay, now fine. Now we had this, and our the thing that we let was y equals to root under x plus 1 by x plus 1. So this was what we let. Yeah. Now this is 2 by x plus 1 by x plus 1 plus 1 dy. Now this thing over here, this is just y square. So we have 2 by y square plus 1 dy. So that's just 2 tan inverse y. Yeah. So 2 tan inverse y. So we are nearly at the end of this solution. And that is 2 tan inverse root under x plus 1 by x plus 1 plus c. And that's the answer. Let's check it. Yeah, that's the answer. And let's check the comments. Okay, done. That's pretty good. It's pretty nice. Yeah, you actually did it quite fast. Let's go to the next problem. Now this problem is not that easy, though it looks monstrous at first. This is not that hard. It's just of some rigor. It's just about doing some rigorous work. Yeah. Now this over here, you can see that this is just 4c1, this is 4c2, this is 4c3, this is 4c4, and this is 1 is over here, 4c0. So it's just binomial expansion of 1 plus x to the power 4. Over here it's 3c2, 3c1, 3c2, 3c3, 3c0. So that's just expansion of x minus 1 cube. And it's going from minus 1 to 0. Yeah. Now the next thing you can do is you can just let the denominator. We can just let the denominator as y. Yeah, so that it will be easier to work on. So you can just let y as x minus 1. And then dy equals to dx. Now integral will be from minus 2 to minus 1. And over here, x will be y plus 1. So this is y plus 2. I don't know why is it going start normally. Okay, start normally. Let's do it. This should not have happened though. Okay. Yeah. Now this is y plus 2 to the power 4 by y cube. Yeah. Yeah. Now after this you can just expand the numerator. Yeah. Let me do it in other slide. No. Okay. Now you can just expand the numerator, and that gives us integral from -2 to -1 y to the power 4 plus 4c1 y cube, sorry, yeah, y cube to the power 1 plus 4c2 y square 2 square plus 4c3 y to cube plus 4c4 to the power 4. We have that expansion, and we can just divide each of them by y cube. Yeah. Now it's pretty easy to integrate this. These are just some powers of y, and we already know like how we integrate y to the power n for any power of n. So this is just some rigorous task that I leave on you to work on. And if we just integrate them part by part, we will get 33 by 2 minus 25 ln 2. So that's the answer. It's not that hard. Yeah, so I'm leaving this on you. 33 by 2 minus 25 ln 2. Yeah. Okay, now let's go to the next problem. So this problem is nice. This problem is just product rule. It's just product rule in this problem. Delete. Okay. Now how we can solve this problem is, you see, here is derivative of sine x, and here is derivative of log x. So over here we just have d sine x log x plus sine x d log x dx. Yeah. So that's this product rule. U b dash plus b u dash. So this is d of sine x log x. So integral will be sine x log x. That's the answer. Plus c. I hope you got the answer. Let's go to next integral. Okay. The next over here is this thing. So this thing is just the integral that can be solved using partial fractions. This one is just a good use of partial fractions. So let me see if there are other members active or not. Okay, great. Yeah, you can do this with partial fractions, and I think it's nice if you are doing this. Yeah. Now over here you can just break this as x, and then x square minus 1 is x plus 1, x minus 1. Now you can use cover up rule to solve this problem. So what cover up rule says is, so let's say we will have three fractions, one of x, other of x plus 1, and other of x minus 1. Now to find the coefficient for the x, first of all try to find out what value of x makes denominator 0. So of course 0 makes it 0. Now substitute 0 in the entire expression over here, in the entire expression. So in numerator we just have 1, numerator just leave the expression that we are now using. Why is that? Start normally. Delete notebook cache. First of all, let's delete notebook cache. Close. Now let's add some page. MIT integration B. Now let's go to. Okay, this MIT. Let's create a notebook then. Yeah. And now this is a new notebook, and that will be a good thing for us. Okay. Now where were we? We were in this problem. Okay. So this was actually integral dx by x minus 1, x plus 1. Yeah. Now we are using cover up rule. We had three fractions: x minus 1, x plus 1. Yeah. Now for x, 0 makes it 0. So just substitute 0 in the inter expression, leaving just covering up the thing that we are using to find the value. This is now doing pretty over. Yeah. If you have said that bricks, it's normal, this is normally, but this shouldn't have happened. Usually it doesn't happen this often though. So now when we substitute x as 0, yeah, and leaving this x that we are using to find the 0, we will get 1 by minus 1 and then plus 1. Now when x equals to 1, just leave this expression and substitute 1 in the other. Yeah, because 1 makes it 0. So 1 by 1 into 2. Over here minus 1 is required. So 1 by minus 1 minus 2. So now if we integrate this, that's pretty easy thing. Yeah. Okay, so basically, okay, so where do I have that? Okay, so basically we will have minus 1 by x, so that minus ln x, and this is, okay, so we had plus x minus 1. So we had minus 1 by 2 ln x minus 1, x minus 1, and then plus 1 by 2 ln x plus 1. That's the answer. Now let's go to another problem. Yeah. Now this problem. This problem is not that hard anyway. Okay, so if OneNote is not working, I can use in Google Whiteboard, which is Jamboard, or I can use Jamboard to solve these problems, I guess, because that will not create such problems. Yeah. Okay. Okay. So now for this one, you can first just let y as sine inverse x. You can just let y as sine inverse x, and that gives us dy equals to 1 by root under 1 minus x square dx. Yeah. Now I can do one thing. I can slightly zoom this so the screen will be larger. Is that? Yeah, let me do this. Now, yeah, we do have this, yeah. Now, and if we do this, our x will be sine y. X will be sine y. So integral will be from for 0, sine inverse x is 0, for 1 by 2, sine inverse x is pi by 6. And x is just sine y, sine inverse x is y, and x dx by root 1 minus x square is just dy. Now this is the new integral. Now use integration by parts. That gives us y, and then minus cos y, minus integral of 1 times minus cos y dy. That gives us minus y cos y plus sine y, and from 0 to pi by 6. Yeah, that gives us, that will be minus pi by 6. Cos pi by 6 is root 3 by 2, plus sine pi by 6 is 1. Yeah, and then minus, that's just minus 0 plus 0. So this is 1 by 2 minus pi root 3 by 2l. So that's the answer. 1 by 2 minus pi root 3 by 2l. Let's take it. 1 by 2 minus, yeah. Okay, great. Yeah, nice. So next problem, this one. This one is also pretty easy problem though. Why did it not drop the problem? Okay, Now for this problem, what we can do is we can just let y equals to 1 minus x, because we want to simplify the expression with highest power, and that gives us dy equals to, or you can directly use King's rule over here. You don't have to let this. You can directly use King's rule. That gives us 0 to 1, 1 minus x, and then we will have x to the power 99 dx. Yeah, this is King's rule. Now this is integral from 0 to 1 of x to the power 99 minus x to the power 100 dx. That gives us x to the power 100 by 100 minus x to the power 101 by 101, going from 0 to 1. At 0, both of them are 0, but at 1 we will have 1 by 100 minus 1 by 101. So that's 1 by 10100. Yeah, so that's the answer. 1 by 100. Now let's go to next problem. And these are pretty good problems, so I hope you are having enough to practice. Okay. Now that's all. Are there anything? Great. Okay. No, nothing. Now for this problem, we can first change sine for x into sine and cos. Integral from 0 to pi by 2. That will be 2 sine 2x cos 2x by sine x dx. Yeah. Now integral from 0 to pi by 2. Again, 2 sine x cos x, and this will be, and the other one will be cos square 2x, cos square x minus sine square x by sine x dx. Now sine x will cancel out. We will have 4 times integral from 0 to pi by 2 of cos cube x minus sine square x cos x. Yeah. Now you can use this beta gamma function. So 4 times 1 by 2 gamma 2 gamma 1 by 2 by gamma 5 by 2 minus 1 by 2 gamma 3 by 2 gamma 1 by 2 by gamma 2. Yeah. And now that gives us the answer. So basically we will have 4 1 by 2, gamma 2 is 1. Over here we will have 3 by 2 into 1 by 2, yeah, minus 1 by 2 gamma 3 by 2. Yeah, okay, so gamma 1 by 2 times, that's just pi by 1. Yeah, now I think we are close to the answer. But wait. Isn't this sine square x over here? So let's do something different over here. Let's take the answer from the answer key first, because what I've done is not believable. 16, it's 4 by 3. I feels like I have made a mistake somewhere. Yeah. So it's gamma 3 by 2, and then over here, oh, it's just gamma 1. Sorry, my bad. And over here it's just gamma it's just 5 by 2. Sorry for that. 5 by 2. So now that is 1 by 2. No need of 1 by 2 now. That's just 3 by 2 over here. 3 by 2. Okay, fine. Now we'll have 4. 2 and 2 cancels out. So that's just 2 by 3. Yeah, minus. Here 2 and 2 cancels out. That's just 1 by 3. So that's 4 by 3 basically. And that's the answer. Yeah. Let's go to the next problem. Yeah. Next problem is this. This one is not that hard actually. Okay. Now for this one we have x to the power. Let me check. Okay, correct. Let me check. Okay, sorry. So for this one we have x to the power 1 by 2 and x to the power 1 by 3. So we can let y as x to the power 1 by 6. Yeah. Let me just make it thinner. Is there a way to make it thinner? Because this is too thick. I don't think there's a way to. Yeah, fine. So we can just use this substitution so that we have y to the power 6 equals to x, and then 6y to the power 5 dy equals to dx. Yeah, that gives us y to the power minus 3 by 1 plus y square dx equals to 6y to the power 5 dy. That gives us 6 times y square by 1 plus y square. Now it's too easy. That's the 6 times y square plus 1 minus 1 by 1 plus y square dy. And that's the 6 times integral of 1 minus 1 by 1 plus y square dy. And that's the 6 times y minus tan inverse y plus c. And now y is x to the power 1 by 6. 6 times x to the power 1 by 6 minus tan inverse x to the power 1 by 6 plus c. That's the answer. Yeah. Let's check it. Let's check the answer. 1 by 6. Okay. 6 times x to the power 1 by 6 minus 6 times. Yeah, that's the answer. Let's go to next problem. Problem number 18. Problem number 18. So this is a pretty standard problem. You know that if we have dx by root under ax square minus b square, so this is just ln of actually there's no a over here in the standard formula, so ln of x, and then is that plus or okay, so that's plus, so ln of x plus root x square minus b square plus c. So that's a standard formula. Yeah. And if we have any a values over there, in that case it's ln of root ax plus root under ax square minus b square, and then we'll also have 1 by root a plus c. Now over here it's just ln of root 2x, not for x, ln of root 2 times x plus root under 2x square minus 1 plus 1 by root 2 plus c. So that will be the answer. Let's check. Okay, so and here's the alternative form, that is ln of you can just take the root 2 out from here. Yeah, you can just factor root 2 out. That gives us x plus root under x square minus 1 by 2. Yeah, times 1 by root 2 plus c. Now that is ln of root 2 plus ln of the other expressions dot 1 by root 2 plus c. Now this gets added to constant CDS, so that's the answer. This is given there in our answer set. Yeah, yeah. Good. Next problem. So this one is also an easy problem. So basically, in the beginning there were some sort of hard problems, but now at the end there are easy problems only. Yeah. Now for this, you can just introduce minus sign over here, and then minus one plus e to the power x minus e to the power x. So you can this is a common trick which you can know. Yeah. The minus one. This is root under e to the power x. But does that help? But does that help? How do you find that e to the power x minus one? Anyways, how will we do that then? Does that help or not? Hmm. It's better to let it. It's better to let that expressions. That will be helpful. Yeah. But this doesn't work. I thought this was the way, so I told it to be easy one. But this doesn't work actually. So when things are messy, we can just try to let the messier things as y. So that's a pretty good approach for most of the problems. So y square equals to e to the power x minus 1. Yeah. And now we'll have dy equals to e to the power x dx. So let's see how do we solve 2y dy. I'm not really sure that if it will be solved or not. So now dx will be 2y dy by e to the power x. Yeah, and then this is just y. Okay. So now this is 2y dy by y. E to the power x is actually y square plus 1, yeah. Nice. So that's 2 times tan inverse y plus c, and y is root under e to the power x minus 1 plus c. That's the answer. Yeah. Let's go to the next problem and let's take it. Yeah. So this is the answer. Yeah. Let's go to the next problem. We are around the end, and this one is pretty easy problem. You can just let x square as y. So if you let y equals to x square, you will have dy equals to 2x dx. Dy equals to 2x dx. Yeah, and so that's just dy by 2 by here it's just y square plus 4. So yeah, we have the answer 1 by 2, and then 1 by 2 tan inverse y by 2 plus c. So that's just 1 by 4 tan inverse y is x square by 2 x square by 2 plus c. That's the answer. That's sick. 1 by 4 times x square by 2 plus c. Now here's the last problem. Yeah, so seems like this last problem is somehow challenging or somehow fun to work on. Okay, so let's see how does that problem go. Okay, let's first try to expand this. 2 dx cos square x minus 2 cos x sin x plus sin square x. So that's 1 minus sin 2x. Yeah. Now we can just change sin 2x to cos. 1 minus cos of pi by 2 minus 2x. Yeah. So integral of 2 dx by, this is 2 sin square pi by 4 minus x. Yeah, to cancels out. So now it turns out this was an easy problem. Cos square x pi by 4 minus x dx. Yeah. Now you can know now we know what's the answer. That's just minus cot x. And then since x has a minus 1 over there, so minus 1 plus c. And minus 1 cancels out actually. So the answer is cot of pi by 4 minus x plus c. Now if you have to bring this to tan, we can just use the formula that tan is just pi by 2 minus the everything. Yeah, so that gives us tan of minus and minus x pi by 2 minus pi by 4, that's plus pi by 4. So that's the answer, tan of x plus pi by 4. Now, okay. So tan of x plus pi by 4 is the answer. Okay, so why is here the different answer though? Why is here a different answer though? This should actually be the answer. Okay, so that's the answer anyways, that's the answer. Yeah. Is this the last problem? Okay, we do have other problem as well. We do have other problems too, but there's no answer. Okay, that's fine. We will just solve them. For this problem, you can let sin as x as y. Sin as x as y. So x will be sin h inverse x. Yeah. Cos x dx will be, okay, sorry, x will be sin h inverse y, and this will be dy by y square. But next, but that doesn't help. I think we can use integration by parts so that we can change x to 1 by taking derivative. Yeah, we can change x to 1 by taking derivative in integration by parts. So x, the integral of this thing, that will be, this is y square and then dy, so minus 1 by sin is x. Yeah, minus 1 by sin is x minus, now x will go to 1 by derivative, and this is minus 1 by sin is x dx. So this is minus x by sin is x plus, this is cos x, and the integral of cos x is ln of tan h x by 2. That's the standard formula plus c. That's the answer. We don't have, okay, yeah, we do have the answer. Yeah? Minus x by sin is x plus ln tan x by 2. Yeah, that's the answer. Good, next problem. This one. Okay, so for this problem, we can basically just let we can just let the thing inside square root. Yeah, and that gives us dy equals to 3x squared dx. Yeah, and then you will have this integral from 1 to 9, and over here the x cube and x square, this can be split into x cube and x square. X cube will be y minus 1, and then root y, and x squared dx will be dy by 3. Now it's pretty easy though. So 1 by 3, integral from 1 to 9. So y to the power 3 by 2 minus y to the power 1 by 2 dy. Yeah. So 1 by 3, this is y to the power 5 by 2 by 5 by 2 minus y to the power 3 by 2 by 3 by 2 from 1 to 9. 1 by 3, this is 2 or 3 to the power 5 by 5, yeah, minus, this is the 2 by 3, yeah, and this is 3 cube, yeah, and then minus 2 by 5 minus 2 by 3, yeah. And then now there are some sort of calculations involved. Yeah, I don't think I'm going in the right direction though. You have to go to I'm going in the right direction, and if you just simplify this, you will get 1192 by 45. That's the answer. Yeah. Go to next problem. This one. Okay. Now for this problem. Okay. Now for this problem, you will also need mass identity. Mass identity is that states that integral from 0 to infinity of f of x g of x dx will equals to integral from 0 to infinity of Laplace transform of f of x in the world of t, Laplace inverse transform of g of x in the world of t dt. So this is what mass identity says. Then you will need that. First of all, you can just let y log x as y. So you can let this as y, and that will give x equals to e to the power y. Yeah. So the integral will be from minus infinity. Yeah, it will be minus infinity. But for the sake of doing it from infinity, what we can do is we can just let it like this. If we let y as minus log x, in that case it will be from infinity. Yeah, minus log x. So we will have e to the power minus y equals to x, e to the power minus y times minus 1 dy equals to dx, and that gives us integral from infinity to 0. This will be e to the power minus 7y minus 1 by minus y times minus 1 e to the power minus y dy. Yeah, is that it? Yeah, minus cancels out. So taking negative sign outside, we will have 0 to infinity e to the power minus 8y minus e to the power minus y by y dy. Now you can use mass identity. So you need to know that Laplace transform of e to the power minus at is 1 by s plus a, and Laplace transform of 1 is 1 by s. So Laplace inverse transform of 1 by s is just 1. Yeah. So now Laplace transform of e to the power minus 8y minus e to the power minus y is just 1 by s plus 8 minus 1 by s plus 1. The Laplace inverse transform of 1 by y is just 1. Yeah, inverse transform of 1 by s is just 1, so that's 1. And then this is in the order of ds. Now it's easy. 1 by minus 1, this is ln s plus 8 by s plus 1, and going from 0 to infinity, both of them are equal, so we will have ln 1 at 0, we will have ln 8 by 1. So ln 1 is 0, minus multiplies, answer is ln 8. That's the answer, which is 3 ln 2. Yeah, 3 ln 2 is the answer. Now we have the last problem. This one is easy. So basically problems at the last were not that hard as problems at the beginning, This is just to trick, maybe just to trick the participants, because they will be trying the problems at the beginning and they will not try at the end, but they should be conscious enough. Yeah. So 1 minus sin square x by sin x, just take the LCM first, and that will be root under cos x dx by root sin x. Now you can just let sin x as y, that gives us dy by root y, and that is 2 root y plus c, and root y is y is sin x, yeah, y by sin x, so that's 2 times root sin x plus c, and that's the answer. That's the answer. So we have basically solved all the problems from MIT Integration B2012. And yeah, I hope you have enjoyed this video. If yes, do like, share, subscribe. Thanks for watching. Yeah. Okay, so Pratik Thapa. Okay, so nice to meet you, Pratik. Yeah, and yeah, I will probably, yeah, do send me some of them. Yeah, I will try to. And some of the integral topics from engineering I'm trying to cover as well. Let's see how it goes. Basically, I'm just trying to upload integrals for now. Yeah. So let's hope it goes well. You can also suggest some of the topics in the comment section of this video or other videos as well. I will try to cover. Yeah, so thanks for watching, and this was it. Next time we will be back with 2013 MIT integration video. Thank you.